In this lecture, we're going to start Chapter P, Prerequisites, Fundamental Concepts of Algebra. And we're going to start with section P2, which is going to cover exponents. Some of this will be a review. The first portion of this, we're going to cover properties of exponents. And what I did up in the top half of this page is I summarized the main properties of exponents. So for example, we have our rule that says if I take a base and raise it to a negative power, that we have to take the reciprocal in order to make the exponent positive. We have the rule that b to the 0 is going to be equal to 1. So if I have a base raised to a power 0, the result is going to be 1. Next, we have multiplying, let's say, b to the m times b to the n. So if I have like bases and we want to multiply the expressions, then the result is going to be the same base, but we add the exponent. So we would have b to the m plus n. We also have the rule over here where we have b to the m raised to the n. So if I have an expression with a base raised to an exponent and then I raise that to another exponent, we multiply the powers. So the result is going to be b to the m times m. Then we have our quotient rule, which says if I have b raised to the m divided by b raised to the n, I'm going to keep the base and subtract the powers. So we're going to have b to the m minus n. Over here, we have a product raised to a power. So if I take a times b and raise that to the nth power, that's equivalent to a to the n times b to the n. And then last, we have a quotient raised to a power. So in that case, I would distribute the exponent to the numerator and the denominator in terms of their exponent. So we would have a to the n divided by b to the n. So these are like our main properties of exponents that we're going to use throughout the semester. So this first section is really just going to practice putting these into use so that when you see it later on in the semester, it's not unfamiliar to you, especially when we get to the chapter on exponents, you'll be comfortable with this. Now, before we begin, let's just be clear because I keep using the word base and then exponent. So if I have, let's say, just b to the nth power, right? B is the base, and then n is the exponent, which a lot of times we also call power, right? So for example, if I had 2 to the 4th power, we have base 2, and then 4 would be my exponent. Okay? So let's practice. Let's look at example 1. So example 1 says simplify using the laws of exponents. So for A, I have 3 to the 4th times 3, and we could also think of that as 3 to the 1st, right? So whenever I see a base and there's no exponent written, the assumption is that it's being raised to the first power. So the result, if we use our rules, right, we're going to have 3 to the 4 plus 1. So we add the powers, and that's going to be 3 to the 5th power. Now, we could simplify that further, right? So we might as well introduce, how to enter a base and an exponent using the calculator. So this will be our first, little calculator lesson in terms of how to use exponents. Many of you are familiar with it, but just in case you need a little refresher, I'll go through this. So let's evaluate 3 to the 5th power. So let me share my calculator screen. Okay, so whether you have the TI-84, the TI-83, it's going to look very similar to the calculator that I have displayed. So we want to enter 3 to the 5th power. So we start with the base 3. And anytime we're going to raise to a power, we could use our caret key or the exponent key. It's above the division key. It looks like a little triangle without a bottom. So that's going to raise now up to an exponent. And we want to raise it to the 5th power. So we're going to type in 3 to the 5th, and then we hit enter. and we get 243. So this is equal to 243. So let's look at part B. So for part B, I have 3 to the 4th, and we're raising that to the second power. So in this case, I have an expression with an exponent, and I'm raising it to another exponent. So that's going to be this rule that I'm circling right here. So in this instance, we keep the base, right? So we're going to keep base 3, and we multiply the exponent. So we're going to have 4 times 2, which is 8. So we're going to have 3 to the 8th power. And again, we could plug that into the calculator. So let's actually evaluate it just to get practice with the calculator. So we're going to take 3 to the 8th power, and we end up with 6,561. If we look at the next one, we have 4 times 2 to the 3rd power. So in this case, I would just take care of the 4 times 2 first, right? So we know that 4 times 2, right? Because oftentimes when we have to simplify an expression, if we have an operation taking place inside of parentheses or group, and if we could simplify that first, I would do that first. So here we have 4 times 2, which is going to be 8, and we're raising that to the 3rd power. And again, we could use the calculator to simplify 8 to the 3rd power. So we're going to take 8, and we're going to raise that to the 3rd power. And we get 512. So that's equal to 512. Now part D, we have a quotient. So that's going to be this rule right here that I'm circling. We have 3 to the 4th divided by 3 squared. So the rule is we keep the base, right? So we keep base 3, and we subtract the exponents from top to bottom. So we're going to take 4, and we're going to subtract 2, and we're going to get 3 squared, which is 9. So we don't need a calculator for that one. Now, if we look at part E, we're going to use the same rule, except now in the numerator, I have 3 squared, and in the denominator, I have 3 to the 4th. So we're still going to keep the base 3, but now I'm going to take 2, and I'm going to subtract 4. So I'm going to get 3 to the negative 2. Now, I did these back to back because I want you to realize that 3 squared and 3 to the negative 2, they're not the same. So let's go to this first rule that I'm circling here, right? If I have b to the negative n, that's equivalent to 1 over b to the positive n. So if I take the reciprocal of b to the negative n, then I'm going to have a positive exponent. And let's just review reciprocal for a minute. So let's get rid of this over here, and let me show you an example. So for example, let's say I have the fraction 2/3. The reciprocal of 2/3 is 3/2. For example, if I have the number 4, right, that's the same thing as 4 over 1. The reciprocal would be 1/4. So if I need to take the reciprocal of 3 to the negative 2, think of that 3 to the negative 2 as being over 1. Take the reciprocal, so now 1 is in the numerator, and I'm going to have 3 now, but to the positive 2 in the denominator. So that's how we handle an expression or rewrite an expression that has a negative exponent. So this is really 1 over 3 squared, which is 9. So that's 1/9, which is not the same thing as 9, right? 9 is way bigger than 1/9. So I just like to point that out because I think that's important, that 3 to the negative 2, let's say, is not the same thing as 3 squared. All right, so moving on, let's look at example 2. We could get rid of this. So we're going to continue using the laws of exponents. We've pretty much used all the laws that were up here, within example 1. So we're going to continue to use the same laws. So let's look at A. So in part A, I have negative 4x squared times 9x to the 5th. Now you see this squared is on the outside of this expression. So what I'm going to do is I'm going to take care of this exponent first. So before I can multiply these two expressions, I have to distribute the 2. So this is equal to negative 4 squared times x squared. So just to go back one more time, I'm using this product rule here. So if I have a product a times b to the n, this is equivalent to a to the n times b to the n. So I'm going to have negative 4 squared times x squared. And then we have to multiply that by 9x to the 5th. Now, negative 4 squared is positive 16. So 16 times x squared times 9x to the 5th. So now I can multiply 16 times 9. And 16 times 9 is going to be 144. And x squared times x to the 5th is going to be x to the 7th. So remember, when I multiply exponents, right, that have like bases, so exponent terms that have like bases, so x squared times x to the 5th, we keep the base and we add the powers. So my answer is going to be 144 times x to the 7th. And let's look at part B. So in part B, I have a quotient now. So I have 14 times xy to the 5th, and we're dividing that by 21 x to the 4th times y to the 4th. So first, let's look at 14 over 21. 14 is not divisible by 21, but I could reduce 14 over 21, right? Both 14 and 21 have a common factor of 7. So 7 goes into 14 twice and into 21 3 times. So that's going to simplify to 2/3. And now I have x to the 1 divided by x to the 4th. So that's going to be x to the 1 minus 4, which is negative 3, right? So remember, when we divide exponent terms with like bases, we keep the base, and I take the difference or subtract the power. So 1 minus 4 is negative 3. And then we have times y to the 5 minus 4, which is going to be 1, or just y. Now notice I didn't put the x to the negative 3 and the y to the 1 in the denominator. And the reason is this is the same thing. You can look at this as 2/3, right? Because 14 divided by 21 is 2/3, times now x to the 1 minus 4, which is negative 3, times y to the 5 minus 4, which is 1. You could think of these as being over 1. So when we multiply fractions, we multiply across the top, we multiply across the bottom. So I would have in the numerator 2 times x to the negative 3 times y divided by 3. But let's write all of our answers with positive exponents only. So we have 2 times x to the negative 3 times y over 3. So the issue really is this x to the negative third power, right? We want to rewrite that. But remember what we do, and we did an example up here. We take the reciprocal, right? So anytime I have a base to a negative exponent, I take the reciprocal and the exponent becomes positive. So you could think of this x to the negative 3 as being over 1. So like I said before, think of this as 2/3 times x to the negative 3 over 1 times y over 1. So if I take the reciprocal of x to the negative 3 over 1, I'm going to end up with 1 over x to the positive 3. So this is going to become 2/3 times 1 over x to the positive 3 times y. So this is going to be equal to 2 times y over 3 times x to the positive 3. And that's going to be my final answer. So notice that x to the negative 3 came to the bottom of the fraction because I took the reciprocal. The y, no issues. It was being raised to a positive exponent, so we leave it where it is. So the 2y in the numerator, and then in the denominator, we have 3x to the third. I'm going to take this opportunity to practice just this concept right here. Whenever you have a fraction, and within the fraction, if you have an exponent term, right, where the exponent's negative, kind of a trick in order to simplify it a little bit faster. So I'm going to go to the whiteboard for a minute, and I'm just going to do a couple of examples. Okay, so for example, let's say I had x to the third times y to the negative 2 over z to the 2. So I just want to rewrite this expression so I don't have any negative exponents. So really the only part of this expression that I have to rewrite is the y to the negative 2, right? Because there's a negative exponent. So you could think of this y to the negative 2 as being over 1. There's a 1 next to the z squared in terms of multiplication, but we just don't write it because it's not going to change the value of z squared. So what we need to do is take the reciprocal of y to the negative 2. So what happens is that is going to come to the bottom and the 1 is going to go to the numerator. So really we're just going to have x to the third times 1, which is just x to the third. And then we're going to have now y to the positive 2. So think of the y to the negative 2. That expression's moving to the bottom of the fraction, and the exponent's going to become positive. And then we still have to multiply that by z to the 2 because that was down there anyway. So that's how we would rewrite this expression without any negative exponents. Let me give you another example. So let's say I have a to the fourth times b to the negative 1 times c to the negative 3 divided by d to the fifth times e to the negative second. So again, I want to rewrite this expression so I don't have any, negative exponents, just only with positive exponents only. So the a to the fourth in the numerator is fine where it is. The d to the fifth in the denominator is fine where it is. But the b, c, and e terms all have negative exponents. So I need to take the reciprocal of each of them. but they all live in this big fraction. So since b to the -1 and c to the -3 are in the numerator, when I take the reciprocal, they're going to move down to the denominator. And then e to the -2, since I want to take the reciprocal of that and it's already in the denominator, that's going to move to the numerator. And e to the -2 is going to become e to the +2 in the numerator. So we're going to end up with a to the 4th. And then times, so let's kind of rewrite the terms that aren't moving, right? A to the 4th is staying in the numerator, d to the 5th is staying in the denominator, but now the b to the -1 is going to move to the denominator. It's going to become b to the +1, or just b. C to the -3 is going to move to the denominator, become c to the +3. And e to the -2 now, once I take the reciprocal, it's going to move to the numerator. So we're going to multiply a to the 4th times e to the +2. And typically, we would write our answer so that it's in alphabetical order in terms of the product. So we're going to write this as a to the 4th times e squared divided by b times c to the 3rd times d to the 5th. So that's the shortcut to rewriting an expression so that you have positive exponents only. Think of, in terms of a fraction reciprocal, and you have to take the reciprocal of any, each and every term that has a negative exponent if we want to rewrite, with positive exponents only. So let's go back to the worksheet. And let's look at number 3. So in example 3, and let me just make this a little bit bigger. So in example 3, we want to practice using the zero exponent rule. So just a quick reminder, a base to the 0 power is equal to 1. So for example, I have -5 times x to the 0. Now just be careful. The only part of this expression that's being raised to the 0 is the x, not the -5. So this is really equivalent to -5 times whatever x to the 0 is, and x to the 0 is 1. So -5 times 1 is -5. And then in example B, I have -5 to the 0 power. Be careful again. The only part of this base that's being raised to the 0 power is the 5. The negative is not being raised to the 0. And the reason I know that is because there's no parentheses here indicating that. And I'm going to show you an example after where there is parentheses and I know that, okay, I have to raise the negative to the exponent also. So this negative really is living out front as like a -1, right? This is like a -1 in front of the 5 to the 0. And 5 to the 0 is 1. So this is really -1 times 1, which is just -1. Now let me show you what I was talking about a second ago. What if I had -5 to the 0 power? You see how that's different now than the way it's written here in part B? Now, this whole expression is being raised to the 0 power, including the negative. And remember, anything raised to the 0 power is equal to 1. So if I have -5 in parentheses raised to the 0 power, my answer is 1. So now let's look at example 4. So we want to evaluate each expression. So evaluate means give a numeric answer. So 7 to the -1. So remember, in order to evaluate a term that has a negative exponent, we have to rewrite that expression using positive exponents only. So let's take the reciprocal. So remember, think of this as 7 to the negative 1 over 1. Let's take the reciprocal. So this is going to become 1 over 7 now to the positive 1. And 7 to the positive 1 is 7. So this becomes 1/7. So let's evaluate B now. So in B, I have -3 raised to the -4th power. So again, I have to use my reciprocal, right? So this is going to be 1 over -3, but now raised to the positive 4. So what's -3 to the 4th power, right? I could evaluate that. That's -3 times -3 times -3 times -3. So my result's going to be positive because I'm taking a negative, right? And I'm multiplying it by itself an even amount of times, 4 times. So it's going to be positive. And 3 times 3 is 9. 9 times 3 is 27. And 27 times 3 is going to be 81. So we're going to have 1 divided by 81. And then in part C, we want to evaluate 2/5 raised to the -3 power. So again, you could think of this as 2/5 to the -3 over 1. Let's take the reciprocal. So we're going to have 1 over 2/5 to the positive 3. And this is going to be equal to 1 over, and we're going to use this rule right here if I have a quotient raised to a power. So we have to distribute that exponent to both the numerator and the denominator. So I'm going to have 1 over, this is going to be 2 to the 3rd over 5 to the 3rd. So this is equal to 1 divided by 2 to the 3rd is 8. And then 5 to the 3rd, 5 times 5 times 5 is going to be 125. But we could write this more simple. You don't want to leave a fraction divided by another fraction. We could simplify that. So let me just remind you, let me go back to the whiteboard for a minute. Let me just remind you how to divide a fraction by a fraction. So for example, excuse me. Let's say I had 2/3 divided by 1/5. Remember, when we divide fractions, we multiply by the reciprocal. So we take the numerator, which is 2/3, and we multiply it by the reciprocal of the denominator. So we multiply it by 5 over 1. And then 2 times 5 is 10, 3 times 1 is 3, and we get 10/3. So that's how we simplify a fraction divided by another fraction. We take the numerator and we multiply it by the reciprocal of the denominator. So let's go back to the example that we were just looking at. So here, I have a 1 in the numerator, or 1 over 1, right? Same thing. Now divided by 8 over 125. So I change division to multiplication. And then I take the reciprocal of the denominator. So that's going to be 125 over 8. Multiply the numerators, I'm going to get 125. Multiply the denominators, 1 times 8 is going to be 8. So my answer is going to be 125 over 8. And we can't simplify that any further, so just leave it as is. So now let's look at example 5. We want to simplify and write the result using only positive exponents. So in A, I have 2 to the -5th divided by 2 to the 3rd. So let's rewrite this division symbol using our fraction symbol, right? So this is the same thing as 2 to the negative fifth divided by 2 to the third. So we're dividing like bases, right? So we keep the base and we subtract the exponent. So we're going to have negative 5 minus 3. Negative 5 minus 3 is going to be negative 8. So we have 2 to the negative 8. And we want to rewrite using only positive exponents, right? So again, think of this as being over 1. We're going to take the reciprocal. So this is going to be 1 over 2 now to the positive 8. And we could use our calculator to evaluate 2 raised to the 8th power. And we're going to get 256. So my answer is going to be 1 divided by 256. So now let's look at B. So I'll do B over here. So for B, I have 3y to the negative fifth times y to the fourth. So I'm going to multiply the y terms, right? So we still have 3 as part of this product, but now I could take y to the negative 5 times y to the 4. So we keep the base. And remember, when we multiply expressions that have like bases, we add the powers. So that's going to be 3y to the negative 5 plus 4. So that's going to be equal to 3 times y to the negative 1. And we want to rewrite this so we don't have a negative exponent. Again, think of 3y to the negative 1 as being over 1. But we only want to take the reciprocal of the y to the negative 1. The 3 is fine where it is because it doesn't have a negative exponent. So the 3 is going to stay in the numerator. And then we're going to have y to the positive 1, or just y, in the denominator. So my answer is going to be 3 divided by y. So let's look at part C. So we have 2x divided by 5, and we're raising that to the negative third power. So remember, when I have a quotient or a fraction raised to a power, we distribute the power to each piece of the quotient. So to the numerator and the denominator. So I'm going to have 2 to the negative 3 times x to the negative 3 divided by 5 to the negative 3. Now, I can't really divide out because in terms of, dividing terms that have like bases, because I don't have an x term on the bottom. I do have an x term on top, but I don't have an x term on the denominator. And I have a 2 in the numerator, a base 2 and a base 5 in the denominator. They're not like. So really all I have to do at this point is just rewrite this expression so that I don't have negative exponents. And then we could simplify, any terms that are left that could be simplified. So let's rewrite this expression. So really, every part of this expression has a negative exponent. So any part of the expression that's in the numerator, if we take the reciprocal, that's going to come down to the denominator and vice versa. If I take the reciprocal of 1 over 5 to the negative 3, then 5 to the positive 3 is going to end up in the numerator. So really, we're just flip-flopping everybody. So we're going to have 5 to the positive 3 in the numerator, and then in the denominator, I'm going to have 2 to the positive 3, and then times x to the positive 3. And now we could evaluate. 5 to the 3 is 125. 2 to the third is 8. And then we have times x to the third. So my answer is going to be 125 divided by 8x to the third. Now let's go to part D. Part D, I have 6y to the negative fourth. This whole product is raised to the negative 1 power. So we have to distribute the negative 1 to each power in this product here. So I'm going to have 6 to the negative 1 and then times y to the negative 4 times negative 1. So I have to multiply the two powers, and negative 4 times negative 1 is going to be positive 4. So I'm going to get 6 to the negative 1 times y to the fourth. Think of this expression as being over 1. And now I could rewrite this as y to the fourth over 6 to the positive 1, or just 6. So we end up with y to the fourth over 6. And let's do one more. So let's look at E. So E, I have 3 squared times x to the negative fourth times y to the negative fifth divided by 3 to the negative 1 times x to the fourth times y to the negative third. So I have a big quotient here, right? It's like a big division problem, and I have like bases in the numerator and denominator. So let's start with the 3, right? So I have 3 to the, now remember, we have to subtract the exponent. So this is going to be a 2 minus, but be careful, we're subtracting a negative 1. So it's 2 minus a negative 1. Now times x to the negative 4 minus a positive 4, and then times y to the negative 5 minus, now be careful again, we're subtracting a negative number. So that's really why I'm using the parentheses, to distinguish the negative sign from the subtraction sign. So this is going to leave me with 3 to the 2 minus a negative 1, which is really 2 plus 1, which is 3, times x to the negative 4 minus 4, which is negative 8, and then times y to the negative 5 minus a negative 3. So that double negative becomes positive, and negative 5 plus 3 is a negative 2. So I have 3 to the third times x to the negative 8 times y to the negative 2. Remember, think of this expression as being over 1. So now let's just rewrite this so I don't have any negative exponents. And we could also evaluate 3 to the third, right? 3 times 3 times 3, which is 27. But now we have to take the reciprocal of x to the negative 8. So that's going to become 1 over x to the positive 8 in the denominator. And then I have y to the negative 2. I have to take the reciprocal of that. So that's going to be 1 over y to the positive 2. So I end up with 27 divided by x to the 8th times y squared. So I tried to really go through and, come up with a bunch of different questions where you had to, apply more than one exponent rule at a time in some instances. And I tried to have a variety, of all the different types of rules. So there's one example left, example 6, where I didn't use numbers for the exponents. So notice in A, B, and C, for example, 6, my exponents are letters. but we're going to treat these the same way. We're not going to do them any differently. So for example, look at A. I have a to the x divided by a to the negative x. So we're dividing expressions that have like bases. So I keep the like base and I subtract the exponents, right? So I'm going to have x minus a negative x, which really becomes x plus x. And x plus x is 2x. So this is going to be a to the 2x. Now, if we look at B, I have 3 to the n times 3 to the n. When we multiply like bases, right, we add the power. So I'm going to get 3 to the n plus n, and n plus n is 2n. So this is going to be 3 to the 2n. So I'm doing these no differently. And then last, I have a quotient. So I'm taking x to the 3n, I'm dividing it by x to the 2n. So again, like bases, so we keep the base and we subtract the power. So I'm going to take 3n minus 2n, which is 1n, or just n. So this is going to become x to the n. So that wraps up section P2 on exponents. In the next lecture video, we're going to begin P3, which is radicals and rational exponents.